Today I will start with DDA Circle drawing algorithm. Okay, we covered Bresenham circle drawing, we covered midpoint circle drawing algorithm. So today we'll cover DDA, that is digital differential analyzer. If you remember, we saw line algorithm as well, DDA line algorithm. Okay, so today we are going to see DDA circle drawing algorithm. Okay, circle algorithm. So just for revision, I will write the long form over here. It's a digital differential differential analyzer. Okay, at the time of line algorithm also I explained it. It takes the differential equation. Okay, so what is the equation of a circle? We saw it many times. X square plus y square, x square plus y square is equal to r square, right? So quickly I will draw a circle over here. Okay, so the circle is drawn. DDA circle drawing algorithm. There is a one center for the circle. Okay, so in for, from the center we are assuming that center is at 0 0. Okay, so here is consider 0 0 is a center position for a circle. Okay, so this is the center, and from this I am going to plot the radius. So say radius is r for the circle. Okay, and from some point we are going to start drawing a circle, that is we are going to consider it as a say xn yn point. Okay, so I will quickly write it xn, sorry, xn yn point. From this point I am going to start drawing circle. Okay, so let's see how it works. Okay, what is the equation is x square plus y square is equal to r square is the equation of a circle. So if you differentiate it with respect to x, what is the value you will get here? Here it is 2x dx. Okay, then plus 2y dy. Okay, 2y dy, sorry, differentiate with respect to x, so it's 2x plus 2y dy divided by dx. Okay, so and here it is, r is constant value, so is equal to 0. Then after differentiating with respect to x, we will just quickly rearrange the equation and we will get the slope of a circle. So what is the slope of a circle? If you calculate it, it will be minus x divided by y. Okay, so in case of line algorithm, if you remember uh, how y is incremented in proportion to the uh, slope, that is y2 minus y1, and x is incremented in proportion to the x2 minus x1, like that. Okay, so same way here we are going to increment the value. If I write the same equation like this, say epsilon x divided by epsilon y, will it going to change? No, I just added some constant term over there. Okay, but it doesn't make any difference to the equation. Why this epsilon value is required, I will explain it quickly. Fine, so just let me clear everything. So rewrite slope, I will rewrite dy divided by dx is equal to minus epsilon of x divided by epsilon of y. Okay, so x is going to increment in proportion. So this is the proportion, dx and epsilon y, dy and epsilon x, like this. X is going to increment by x plus epsilon y. okay, x plus epsilon y. What about y? Y will be incremented as y minus epsilon of x. Okay, this is the next value of y basically. This is the next value of x basically. This is the previous value and this is the previous value. Okay, so this is the increment proportion to dy divided by dx. So you'll get the next pixel like this. Fine, here it is yn, here it is xn. Okay, so we are going to use it every time. Say from some point we are going to draw a circle. Okay, then say this value is r, which I already explained. Here is the point xn comma yn. Okay, while drawing the next point, this is the tangent. Okay, sorry, this is the tangent to a circle. Okay, tangent to a circle. This is the tangent slope, you can say, to a circle. Okay, then next point, whatever we are going to draw, if you observe, some error get added. Okay, this error is negligible basically. X n plus 1, y n plus 1. This is the next point somewhere again, which is somewhat more than r value. Okay, some error is added every time when you are going to, again you need to uh, draw a tangent from this particular point. So I will draw it properly. Okay, from this particular point to a circle we are going to draw a tangent again. Okay, and again we are going to decide the next point. Hence you need to go on creating the circle, okay, by adding different point, but the circle won't get close properly at the first point. Okay, or the circle won't get close properly here, it will get close somewhere here. Why is it so? Because every time small error is getting added inside while creating the circle, and at the end the circle not get close properly here. Okay, that's why we need to do one modification over here. The same equation you can represent in matrix format as well. Okay, x n plus 1 y n plus 1 over here is equal to xn. If you multiply these matrices, you will get the same equation over here, 1 minus epsilon, epsilon plus 1. How? See here, first row, first column, xn plus epsilon yn. Yes, that is the value of xn plus 1. What about yn plus 1? Minus epsilon xn plus yn, here you will get. Okay, so this is just a representation in terms of matrix. Now we'll see what error is added, basically how much is the error. Okay, for that we will square it. Xn plus 1 square, xn plus 1 square, let me clear it. We'll continue with this equation. xn plus 1 square, okay, is equal to, what is the value of xn plus 1? Just now we saw that xn, okay, then plus epsilon of yn, okay, square it. Then similarly yn plus 1 square is equal to yn minus epsilon of xn, here it is square. Okay, square xn plus 1 here, xn square plus 2 into xn epsilon yn plus epsilon square yn square. Okay, similarly here yn square minus 2xn epsilon of yn, okay, plus epsilon square xn square. Fine. So if you add both the terms, okay, add 1, equation 1 and equation 2, add 1 and 1 and 2, okay. After that, which value you will get here? Xn square plus yn square, okay, plus epsilon square, okay. Then here again xn square plus yn square. Got this value? Yes, we can have again xn square plus yn square common from both the terms, and here it is 1 plus epsilon square. So this is the particular error. So this is Rn plus 1 square xn, okay, sorry, xn plus 1 square plus yn plus 1 square. This is, can I say, x square plus y square is equal to r square. So this is Rn plus 1 square is equal to, this is Rn square, okay, and here it is 1 plus epsilon square. But what we want, yes, we want basically your our Rn plus 1 square should be equal to Rn square only, right? We don't want this particular term, or you can write it further as Rn plus 1 is equal to Rn square root of 1 plus epsilon square. This way also you can write the same equation. But as I said, we don't want this particular term, right? We want to remove this term. So that our Rn plus 1 will be equal to Rn and circle will get closed properly. Okay, let's see how we can do that. Okay, so here again, previously I represented the matrix equation. Okay, I have shown you the calculation how we did it. Okay, yn plus 1 is equal to matrix representation xn, sorry, xn yn, okay. We saw this representation 1 minus epsilon 1, right? Then see, instead of doing calculation of all these things, you just need to calculate the determinant of the matrices. Okay, so the same value comes basically. I have shown you that already. Okay, is equal to xn square plus yn square. So this is the simple way, 1 plus epsilon square. Simply take the determinant, okay, of a particular matrix, so you will get the same term. Fine. So this is the equation, and as I said, we don't want this particular term. Let's see how to remove this term. So through the experiment, it came to know that the term will get removed. So this particular thing should get 1, right, after multiplying this. So how you can make that? Let's say how you can make that. Xn, yn, I'm just going to modify this particular matrix now. 1 minus epsilon, okay, and epsilon into 1 minus epsilon square. Now calculate the determinant of each matrices. Fine. Sorry. Yn plus 1. Now calculate it. What you will get here? Xn square plus yn square over here. Calculate the determinant. xn plus 1 square plus yn plus 1 square. Calculate the determinant. It's 1 minus epsilon square plus 1, so it gives you 1. Okay, now can I say my Rn plus 1 square is equal to Rn square, or can I say Rn plus 1 is equal to Rn? Definitely yes. Okay, so this is how we did it for the DDA line algorithm. So what is expected? What changes are expected in the equation? Yes, x value will be n plus 1 is equal to xn plus epsilon yn only. But while representing the next value of y, what we need? Yes, yn minus epsilon of x n plus 1. So whatever previous calculated value you got here, the same value you need to use there. Okay, as soon as you will get this value, you need to write this value over here. Fine. So again, if you want to know how this value came for yn plus 1, okay, so just I will write it. Yn plus 1 is equal to yn minus epsilon. Can I replace xn plus 1 is equal to xn plus epsilon of yn? Definitely yes, right? So here it is equal to yn minus xn into epsilon, or epsilon xn plus, sorry, minus epsilon square yn. Okay, so just have a yn term differently. Yn I will take common, it will be 1 minus epsilon square, and here it is epsilon into xn. Okay, so that's why we can represent it in a matrix like this: xn, yn. Another matrix is 1 minus epsilon, and epsilon 1 minus epsilon square, like this. Okay, so you are getting the same values. Multiply first row, first column, xn plus epsilon yn. Yes, we got it for xn plus 1. What about yn plus 1? Yn plus 1 will be now minus epsilon xn. Yes, minus epsilon xn is there, and 1 minus epsilon square into yn. Okay, so this particular term will be 1 now. So in this way, this is the explanation for DDA circle algorithm, digital differential analyzer. Okay, I hope the concept is cleared. Okay.